So thank you for coming to the last session of this DevFest. Who am I? Just a minor correction on the introduction. I'm not a Google developer expert on Android, but on cloud. And I'm also a platform engineer at Telefonica. That what I do, I will explain a bit later in the presentation, but mostly manage containers and doing big data stuff. And also, I'm also active at the organization of events by doing some meetups in Spain, in Madrid. So first of all, I would like to start doing a brief history of the centralized computing. In the 40s to the 80s, there was like the beginnings of the computing, and because it was everything very expensive, there were the time of the mainframes. So there was no like smartphones or PCs at homes, and there were huge mainframes at universities or Department of Defense in the case of the United States, and everyone go to a building to connect to it. Later, in the 80s, it started to appear all about the personal computing. So with personal computing, everyone at its home will get a personal laptop. And it also begins the movement of the internet. So the mix of these two make a tendency that allowed us to connect to these mainframes and work with higher power. But finally, around the 2000, it was everything like using PCs, and we were connecting to sites, but we were not working with huge mainframes until from 2000 to 2020. Oh, there's a typo. So at this time, everything changed and started to appear the social networks like Facebook, but also started to appear clouds like AWS, Google Cloud, etc. And all these personal computing devices started to working again into a centralized way. So after that, in 2020, well, I don't know, of course, we didn't reach that yet, but there are probably two flows. To keep centralizing everything, and we just will work with small terminals, but they don't need power. That's maybe some tendency like for gaming using Stadia, because we will play remotely and all the power will be done in data centers. But we maybe also can come back to the centralization, because all these technologies like Bitcoin or blockchain, they are focused on not having a single point of failure, but being distributed among us. So only the future will say. But focusing on now, there is a thing that, about that affects us as developers. Who in the room are a developer? Consider us a developer? Okay. Who of you considers us an operator or ops? Okay. When we are developers and operators, there came a later technique called DevOps. This technique allowed us to combine the knowledge of these two disciplines. And it started to appear in the last 2 or 3 years a methodology called cloud-native applications. And these cloud-native applications is basically the wrap of microservices, the wrap of automation, and the wrap of not having to depend on external dependencies. It's something like what Java started in the beginning, like putting jars and everything else, but for all other technologies or newer technologies that keep working. So, cloud-native applications are all these 3 bullet points. But how we do develop them? So this, in fact, is a sad thing, because we are developing them in the traditional way. We are not getting mostly the benefits of the cloud. We are using the benefits of the cloud, that is that small centralization we are living right now, in our production deployments and in our CI, continuous integration, but mostly not in our development iterations. And what happens with this? That if I am depending on a laptop like this, that is so thin, and even if they cram it with a lot of memory, sometimes my application that will run big data will not be able to build or run on my laptop. So, or some other times, we are working more and more we work more and more remotely, not in the office, and we depend a lot on the mobile networks connecting through 4G, for example, and we cannot download too many dependencies. Have you tried, for those that do Java, to download Maven, your Maven dependencies over a 4G? A lot of latency, right? When downloading the internet, or NPM. So that's the summary. We have very slow iterations, high inefficiently builds, and very badly reproducible. This is why it will be the wish list. That's what we will want on demand. Instead of imagine that you are running a laptop, but you need in a specific moment 64 gigabytes of memory. I think there is no thin laptop that has that yet. So imagine that your process needs that. What is the solution now? Maybe doing some swap doesn't make sense because it will get even slower. What about collaborative capabilities? What if you want to enhance another colleague that can access your work or can share a port? There are like very small tools, the ones that I'm going to show you later in the presentation, but they are not generalized. And finally, what about isolation? This got resolved 3 years ago by Docker, so we can get reproducible and isolated builds, but it's still not a thing because there is no easy way to start developing containers and later deploy them on production. What I mean by that, the runs on my local phrase got reconverted runs on my container. So that's the number one excuse for us developers to say, oh, it's run on my container, why is it not running on yours? Because there are still dependencies along the way, maybe network, maybe cloud services, etc. So that is cloud native development, the thing that I'm going to show you next. But first, let me explain what I do on my daily basis. That it's platform engineering, and mostly it's a 70% development and 30% operations. What I mean by that, I am continuously automating things. Even the failures that happen real time, I try to avoid getting into a system and fixing in place. But I try to make a commit or an automation, move it to my pipeline, and fix it through the pipeline. Except the very, very bad ones, of course. Do you know this one? That I don't know how to fix your printer because I manage all of this. If you want this postcard, you can send it to your family to explain what your job does. So this is basically me. The bad thing about being a platform engineer instead of a backend engineer maybe is that with backend engineer, you focus on a specific language or some kind of languages, and platform is like the new but call it DevOps engineer. They throw all at you. You need to know about how Ruby dependencies work, how NPM dependencies work, etc. Something like that. So my wish list for developing all these kind of things and trying to be able to enhance my platform when working with multiple technologies is that I don't want to care if I need a technology or another in my laptop, even when I am abroad or at sea. So I would like to make a small recap about the wish list of a developer. So we want to do collaboration. We solved that with Git. We want reproducibility. We started having makefiles, dependency managers, more dependency managers. And later, we want isolation. How we achieve isolation? Because before virtual machines, we started to mix up everything. How many of you mixed up your Python environments, installing one version of a dependency and another one in another project and making them collide? That's a very common issue. So to make reproducible builds and to remove that phrase that is works on my machine, we started using virtual machines on local. But setting up a local machine it takes time. I mean, you need to go to VirtualBox, click, and create a new machine. It's hard. Why don't we use templates? That's why when it came Vagrant. So we could spin up machines in our laptop in an automated way. But we have performance and efficiency issues, because how many virtual machines you can keep up? What happens when the microservices exploded? If you start having multiple services, you are not going to spin up a virtual machine for each one. So that got solved with Docker, because instead of reserving all your memory for each virtual machine, you could share it with Docker, and you get performance and efficiency issues. But okay, yeah, the thing with this GIF is that you start moving all these kind of technologies, and you lose some collaborations and reproducibility. For example, until Docker, the reproducibility was not perfect, because it got recreated on each virtual machine. So it's just like trying to complete my wish list. But finally, these are the 2 points. Do you agree with me that these 2 points are the most critical ones when developing locally? Because with security, how many times do you import or download a dependency that is public and may have security issues? Did it pass it through your security team at your company, or you just npm install random guy.package? And the other one is resiliency. When I started working at Telefonica, and my delivery process, where it ran it inside my laptop, there was a problem with that sometimes there were random errors of DNS, random errors of my own laptop that was hot, it was out of space, many things that would happen. Or just that my laptop, this cup of water falls into it. I mean, if I have maybe an accident with my laptop, I will lose my development. So I will need to start again back. Oops. Or fire. So I think about one thing, how bad it will be to develop on virtual cloud, on virtual machines in the cloud. Sorry. Okay. So we solve the last 2 points, security and resiliency, by using infrastructure from providers, say Google, say AWS, say whatever provider you want to use. We'll solve resiliency and security with this kind of infrastructure, because they are the ones that they are very good at it. So the unique point about that is that you will need, of course, internet connection, but you will get scalable power or security measures, so your machines doesn't see others, or that doesn't get contaminated by others. I want to introduce a specific thing about Google Cloud, that you have a always free virtual machine. So for you that you are students, you can spin up a specific machine. It's small, but you can have it for free, 24 hours, years. I mean, it's not a free tier that lasts 12 months, so you can have it like your Jambox, maybe for hacking and all that stuff, or for students if you want to have a specific VM or VPS to run something. So my wish list starts again. So what happens with the remote connection? What happens with the billing? So the remote connection, I solve it with Temux and Mosh. And the billing, I solve it with Cloud Build. What does this mean? I will demo these 2 things separately. So the remote connection to the machines, it used to be through SSH. And what happens to SSH when you probably have packet drop? You will need to restart your session, right? It's a hassle. It's the bad thing of developing remotely. And the other one is billing. Okay, I am spinning up, again, a virtual machine in the cloud, but what happens if I need 64 gigabytes? Okay, I can scale out, but I need to also pay it. So what if the problem is that I left a build and I forgot about it, or if I'm not able to set timeouts, all that kind of automation, it can be done with Cloud Build. I'm going to demo that. Okay. So please see that I am tethered. I'm not on Wi-Fi. So everything is running on 4G. Now let's cross fingers and so on the left, you will have a Docker build that it will take about 3 minutes in local, running locally here on my Docker for Mac. And on the other side, we have the G-Cloud service. That is like a remote daemon for building Docker images. So let me launch them at the same time. The first one does start to uploading your source code to your Docker daemon inside your laptop and start working. But you are starting to see the downloading speeds through 4G. And in the other side, on the right, it sends again your source code, but it uploads it. So you can see it up in the top. Where is my mouse? In the top line, how much size does it upload? 2 kilobytes or 10 kilobytes. These 10 kilobytes, they are hyper fast because they are uploaded locally to the Docker daemon. And this other one, they are 2.5 kilobytes that they get uploaded to Google Cloud. But the left one needs to process all our Docker files and will start downloading the images back to local. Instead, on the right, a remote executor of Google Cloud will run our images. So it's still loading, and maybe this one end. Yes, it ended in 44 seconds, and this other one took 1 minute 14 seconds. Yeah, that's not much a difference because it worked very well on this demo. So normally downloading an image, it takes much longer. But you can have constant and reproducible builds in the cloud using the service on the right. And the other one is Tmux and Mosh. So let me start with this one. So I just SSH into an instance in the cloud just to start developing there. And I can run commands. It will get updated, but everything that runs here needs to come back to my laptop, to my client, in a sequentially order. So what happens if I do, for example, a command like that? It will start popping lines, and I disconnect this. Oops. Maybe an internet connection failure. I should go back internet now. Maybe? Yes. But your session SSH broke. And maybe your all the content that you were doing. How can you solve this? Using Tmux. Tmux is a terminal multiplexer that allows us to attach and detach from the virtual sessions and also start to partitionate your virtual terminal into multiple ones. And the same test I'm going to do here. I'm going to start a ping. I'm going to remove my internet connection. Oops. And of course, it doesn't come back. But when I hit Control-C and the packet write fails, I can go back to my SSH and make Tmux attach. And I'm still back at my session, so I can keep working on it. Tmux is a very old thing. It's not something that appeared yesterday, but I recommend you to learn it because it makes you more efficient working on remote connections. So on the left, on the right, let me submit this. What I want to introduce is the next thing, because logging in and logging back into your session in Tmux is still inconvenient, right? Because you didn't get it when it break it. You don't know if it's waiting your command or whatever. So Mosh is a technology that will start a cell and use a very specific protocol to stream the cell that you are viewing, some kind like YouTube or Stadia. So I'm going to do the same thing. I don't need to use Tmux here, but it's useful. It's useful also. Let me open it here. So both are running pings, and I will disable my internet connection again. And with the red one, you get instant feedback that something broke. But what happens when I plug it in back? Boom, you're back. So imagine that there are some interruptions, maybe traveling on a train, a small internet cutouts, or maybe you just want to switch from the Wi-Fi to the Ethernet connection. Mosh got you covered. Of course, there is a bad thing about that. On Mosh, you can scroll up. That's a bad thing, because it's only streaming you the thing that you can see. So how can you solve it? Using Tmux. I want to remove this one. Yeah. So when you're using Tmux, or maybe let's cut something. When you are using Tmux, you can scroll back up. So you can solve that flow of Mosh. OK. So going back to my presentation, I had another one more thing to show you, that is Scaffold. Scaffold was a beta thing that got released almost 1.5 years, and it allowed us to do builds with live reloading into, for example, Kubernetes clusters. So it's like the automation of everything, in this case for your developers. But it got a version 1.0 yesterday, so it's a big milestone because it got everything stable. I mean, the API will not break. And what's the thing about this? Let me show it to you. OK. So when you run Scaffold dev, what it will do is to scan your directory and to start looking for a source code to build. It will build it automatically on every change, and it will push up directly into your Kubernetes cluster. What does this have to relate with my previous slides? That even when working on the cloud, I will still need to do that flow. That is, make a change, Docker build, Docker push, and Kubernetes update something. So with the Scaffold, you're automating all these three things just in a live reload way. So let me show it to you. A simple application. I didn't want to get the things back, but it's the same Docker file, that Docker image that we built previously. Oh, let me show you previously that it works. 1 second. I'm forwarding the pod. So of course it answers back. And if we change this to hello DevFest Prague, when I hit save, the Scaffold detects it and starts building automatically my image. But the cool thing about this is that you can use it with this service, that is Google Cloud Build. It has many plugins. You can build your image locally and push it locally. You can build it through a remote service. So in this case, Scaffold is already integrated with Google Cloud Build, and on every change, it will upload my source code, and Google Cloud Build will start building it, pushing it, and finally updating my pod. The same happens for 40 seconds. And it uploads it. So when I hit here, because the tunnel broke. Hello, DevFest Prague. This can be even faster if you do the local builds, but with internet connection, of course. But if you are, for example, abroad, hotel Wi-Fi, or whatever, you can still do these automations with remote executing builds. Docker building, Docker remote execution, will be the most simple one because it's compatible let's say, with almost each workflow. But Scaffold is also compatible with using technologies like Bazel. And Bazel allows you to, it has plugins and allows you to do remote building of Java artifacts. And what it can do is that it will ask another service of Google Cloud, to build your Java application as most parallelly, or as most concurrently as possible. So that's the note about Scaffold. And I want to thank you for coming to these slides and to this talk. Hope you have more questions to deep dive into them, or you can get me back after this. Thank you.